Hey guys, Mrs. Jockel here, ready to take on our third math lesson for this week. Today we are going to be doing lesson 12.8, and it is all about classifying polygons and sorting them into different categories. So we'll be doing a lot of comparing and contrasting and looking to see what some of these shapes we've been learning about have in common with one another. So go ahead and grab your book and open up to page 741. All right, so if you look at the unlock the problem, we are going to look at a Venn diagram, and it shows how things are related. In the Venn diagram to the right, one circle has shapes that are rectangles, and then shapes that are rhombuses are in the other circle. And then the shapes in the section where the circles overlap are both rectangles and rhombuses. And it says what type of quadrilateral is in both circles. So we are looking for the specific type of quadrilateral that we see in the middle of both circles. So we're looking for what kind of quadrilateral would be rectangles, but also rhombuses. And you might have an idea of what type of quadrilateral that is based on the picture that you see, or based on your knowledge of rectangles and rhombuses, and how there is one very special quadrilateral that can be classified as both. But we're going to walk through the steps together. This is our problem-solving lesson, so we want to make sure we are explaining what we're doing and following step-by-step directions of how to solve the question. So what do I need to find? Well, we look back at the question for that. We need to find what type of quadrilateral is in both circles. So I'm going to type just that. Let's get it back over here. So the type of quadrilateral found in both circles. Got my L in there. There we go. So that's what we are trying to find, the type of quadrilateral found in both circles, or the middle of the Venn diagram. What information do I need to use? Well, we need to use those two circles, the circles labeled rectangles and rhombuses. Okay, so we need to use those two parts of our Venn diagram in order to solve this problem. How will I use the information? So we're going to make comparisons. We're going to, so let's say I will describe the rectangles and rhombuses and see how they are similar. Okay, so we're going to be looking for some comparisons between these two shapes and how some of the shapes can classify as both. So let's think of some questions here as we solve the problem. What is true about all quadrilaterals? What do we know about every single quadrilateral? Okay, so they have 4 sides and 4 angles. So we know all quadrilaterals, whether they are squares, rectangles, rhombuses, parallelograms, trapezoids, all quadrilaterals have 4 sides and 4 angles. Which quadrilaterals always have 2 pairs of opposite sides that are parallel? Remember, parallel sides are the opposite sides that will never cross or touch. They are always spaced the same amount away from one another. And so when we think of the quadrilaterals that have 2 pairs of parallel sides, I think of rectangles, because the top and bottom of rectangles and the sides are parallel. Squares have opposite sides parallel. Rhombuses have opposite sides that are parallel as well. And then another shape that we didn't talk a lot about in our book, but the parallelograms, those shapes also have opposite sides parallel. Which quadrilaterals always have 4 sides of equal length? Okay, so the ones that always have 4 sides that are equal are squares and rhombuses. Okay, which quadrilaterals always have 4 right angles? Rectangles and squares always have 4 perfectly right angles. So when we think about this, which type of quadrilateral did we kind of list in each answer? I'm seeing a common word: squares, squares, and squares. So could it be that those shapes in the middle of our Venn diagram are squares? Because squares can technically be called rectangles because they have 4 right angles, they have 2 pairs of parallel sides, and opposite sides are equal. And yet squares are also considered rhombuses because a rhombus just has to have opposite sides parallel and all 4 sides equal, which squares do. So I think we found our answer here. So the quadrilaterals in this section where the circles overlap always have 2 pairs of opposite sides that are parallel, top and bottom, side to side. How many sides of equal length? They have 4 sides that are equal in length. And how many right angles? 4 perfectly right angles. So to answer the question, what kind of quadrilateral is in the middle? We determined that they are squares. Okay? So that just goes to show some similarities between the quadrilaterals that we had learned about. Not all rectangles are squares, but some squares can be considered, or some rectangles, can be considered squares. And just like not every rhombus is a square, but some are. All right, if we go to try another problem, on the next page, it says the Venn diagram shows the shapes Andrea used to make a picture. Where would the shape shown below be placed? So if we look at this shape that Andrea has, and she needs to figure out where it goes, so we're looking at this shape right here. I'm going to circle it. We need to figure out if it would go under quadrilaterals, or polygons with right angles, or maybe it needs to go in the middle, which means it's both a quadrilateral and a polygon with right angles. So what do I need to find? Where does the shape belong? That's what we're trying to figure out. Where does that shape go? What information do I need to use? Okay, we need to use the Venn diagram because we need to look at the information on the Venn diagram in order to understand where to place that shape. How will I use the information? I will compare quadrilaterals and polygons with right angles, because those are the 2 categories that are in our Venn diagram. So we're going to need to use that information and compare it to one another to see where that particular shape needs to go. So let's record the steps that we will use to solve the problem. So let's start with the first category, quadrilaterals. What do we know about quadrilaterals? Quadrilaterals have 4 sides, 4 angles. We know that, okay? Does this shape have 4 sides and 4 angles? Yes, okay, so this shape does. Let's look then at polygons with right angles. What do we know about that category? Well, we know that polygons with right angles, they have to be closed shapes. Polygons have to be closed. They have to have straight sides. And then a right angle has to have, oops, perpendicular lines, you know, where they are coming down. And hey, if you need to, guys, even draw a little picture of that. What am I trying to do here? All right, so, you know, you could draw a quick little sketch. Like, hey, here is what a right angle looks like. And when I said perpendicular lines, it just simply means that where those line segments touch, they're forming that perfect right angle. So now that we have gone through the two categories, we can try to identify where this shape would belong. Okay, so the shape has 4 sides, 4 angles, and it has 1 right angle. So it belongs where? In the middle of the Venn diagram. Why do I feel like I spelled diagram wrong? Looks funny. Okay. So the shape would go in the middle because it is a quadrilateral, being that it has 4 sides, 4 angles, but the shape also has a right angle. And I'm just going to draw the shape a little bigger over here. Not going to be my best artwork, but here's where the right angle is. Actually, I lied to you guys. There's 2 right angles. Huh. See what you learn whenever you go over your work? There we go. It has 2 right angles. I was just looking at that bottom corner. All right, and I know someone in class would have stopped me and said, wait a second, Mrs. Jockel, there's 2 right angles. But since we're at home, nobody's here to yell at me and point out my mistakes. But hey, we're in this together, we're all learning together, and mistakes do happen. It is simply proof that we are trying. So guys, let's go to our questions down here. How many shapes do not have right angles? So when we go back up to our Venn diagram and we look, how many shapes out of all of the ones in our Venn diagram, how many do not have right angles? So simply put, how many shapes are just in the quadrilateral section? And that would be 3. Okay, the 3 shapes on the left-hand side of the Venn diagram are quadrilaterals, but they do not have right angles. Remember, the ones in the middle do have right angles as well as being quadrilaterals. Number 2, how many red shapes have right angles but are not quadrilaterals? Okay, now they're just getting fancy. How many red shapes, so we're specifically looking for red, how many red shapes have right angles but are not quadrilaterals? So that means we are looking only on the right-hand side of our Venn diagram, just at the polygons with right angles. And out of the 3 that I see, only that top one, that top triangle is a polygon with a right angle. So 1 shape. Okay, there's 1 red shape. Okay, number 3, what is a different way to sort the shapes? So now they want us to think of another way that we could sort our shapes. Because when you think about sorting items, let's just say, for instance, Lego pieces. We could sort Legos by their colors. We could sort Lego pieces by their what shape they have. Some are bricks. Some are like the little circle dots. This is where I need Jeff to help me out with some Lego pieces. But you get the idea is that in life, there's usually a lot of different ways that we can classify things. You know, even off the top of my head, I'm thinking of fruit. We can classify fruits by the types of fruits that they are, by their color, by their sizes, by their shapes. So there are other ways we could sort these shapes up in our Venn diagram. So what do you think we could do? How could we do that? Well, we already have them sorted as quadrilaterals, so that's having 4 sides, but not all of those shapes have 4 sides. So we could maybe sort them by triangles, although there's only 1 triangle, or we could maybe look at the types of sides that they have, because I look at a lot of those polygons have parallel sides to them. So we could sort maybe by polygons that have parallel sides, and then polygons that have right angles, and then maybe polygons that have both, because there are a few that have a right angle but also have parallel sides. So let's just jot down, we can sort the polygons by their parallel sides, right angles, or number of sides that they have. Those are just some different ideas of how we could sort those shapes. Okay, not going to spend too much time there. So let's move on to the next page here, the share and show. And the share and show wanted us to look at these 8 shapes off to the right of the page. And Jordan, she is sorting them into the Venn diagram, and we need to kind of figure out where the shapes would go. So I kind of recreated the shapes over to the right-hand side of my screen just so that I can move them. So help me out here. So the green rectangle, oh, so our categories, I made a bigger Venn diagram. We have right angles, and then we have the right-hand side says all equal sides. And then in the middle would be shapes that have right angles and all equal sides. So the green shape I have here is a rectangle. It does not have all equal sides. So therefore, I'm going to put it over on the left where my right angles would be, because it does have right angles. Let's go to the red triangle here. Does it have all equal sides? No, it certainly does not. So it won't go here. It won't go in the middle. It does have a right angle though, because it is a right triangle. How about this green triangle? Does it have right angles? No, so therefore it won't go in the middle either, but it does have all equal sides. My purple square, does it have right angles? Yes. Does it have all equal sides? Yes. So it will go in the middle. And then the pentagon right here, my 5-sided shape, my pentagon, does it have all equal sides? No. Close, but not all equal. But it does have right angles, so it would go over here. I have another pentagon, and this pentagon, because of how the 2 sides of the pentagon, the bottom sides, kind of slant diagonally in, all those sides are equal, but does it have any right angles? No, so it's going to go just on my all equal sides. This shape here, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so an octagon here. Does it have all equal sides? No, but does it have right angles? Yes. And my last shape, this pink one here, does it have all equal sides? Yes. Does it have right angles? Yes, actually. So it will go in the middle. And so now that we have those shapes kind of sorted, it might help us see where this other shape Jordan has, where it needs to go. And I'm going to see if I can get that shape that Jordan has. Okay, so I'm back here, and I did my best to recreate this shape here from our problem that Jordan has, and she's trying to figure out where it would go. Is it a shape that has right angles? Does it have all equal sides, or both? So first, look at the sides and angles of the polygon. And next, draw the polygons in the Venn diagram. Okay, so we kind of already sorted them. So if you didn't draw those shapes down in the Venn diagram, go ahead and pause the video and do that. The shape that Jordan has here, this green one, it has how many sides of equal length? I know my picture isn't quite accurate, but all 4 of those sides actually are the same length. And how many right angles does the shape have? Actually has 0 right angles. So where is this shape going to go if it has all equal sides but 0 right angles? It's going to go on the right-hand side with our blue triangle and our pentagon. Okay, so it will go under, polygons with equal sides. Okay, so we figured out where that shape needs to be. But then now there is this other shape that they're asking for us to place. It has 4 sides. I didn't really do a good job of drawing that. Okay, as good as it's going to be. Now we need to figure out where this shape belongs. Where would you place it? Does it have all equal sides? No, it does not, but does it have right angles? Yes, it does. So we are going to, oh my goodness, I'm beginning to really not appreciate technology the way it works. Oh my gosh. Okay. All right. Yeah, I just want to grab this shape. Ooh. Okay, so it's only going to go on the side with right angles. Polygons with right angles. All right. What if Jordan sorted the shapes by polygons with right angles and polygons with angles less than a right angle? Would the circles still overlap? So if she got rid of all equal sides and instead she had polygons with right angles and then polygons with angles less than a right, which would be acute angles, would we still have the center? Okay, so if we changed the right-hand side of our Venn diagram to be acute angles, the 2 squares in the middle would need to move out because they do not have acute angles. However, are there other shapes that do have acute angles? Well, the 3 on the right-hand side all have acute angles and no right angles, so they're going to stay. How about the shapes that are over under right angles? The rectangle has all right angles, so it would stay. The octagon, the blue octagon, has all right angles, so it would stay. How about this red triangle, though? It has a right angle, but it also has 2 acute angles, so that would go in the middle. The pentagon here has right angles, and then it has obtuse angles. But this trapezoid, this purple trapezoid, would go in the middle because it does have right angles, but it also has that acute angle in the top corner. So even though some of the shapes would change where they are positioned, we would still have the overlapping section in the middle. So we would say, would the circles still overlap? Yes, because some polygons have both right and acute angles. So they would have to go in the middle. All right, and number 4, Ava drew the Venn diagram below. Write labels that she could have used for the diagram. So I'm going to see if I can zoom in a little bit because I know it's kind of faded a little. So I know looking in your book might be a little better. Okay, woo, there we go. So looking at this Venn diagram down here at the bottom, we need to see if we can come up with labels. So we need to see what these quadrilaterals or what these shapes have in common. And I said quadrilaterals only because looking at the left-hand side of the Venn diagram, I noticed that all of those shapes are quadrilaterals because they have 4 sides, and the shapes that are in the middle are also quadrilaterals because they have 4 sides, but the shapes over on the right-hand side, they are not quadrilaterals. Well, one's a triangle and one is a quadrilateral. So I think we could say over here we have quadrilaterals. But we need to add something more to that because there's still a quadrilateral over here on the right-hand side. So what do we notice about the quadrilaterals on the left? Look at the sides. Quadrilaterals. Each of these quadrilaterals has at least one pair of parallel sides. So we could say quadrilaterals with parallel sides. And it doesn't have to be all sides parallel. And then what do we have on the right-hand side? One shape is a triangle, one is a quadrilateral, but it doesn't have any parallel sides. We could say, I don't know. My book is saying quadrilaterals, or I'm sorry, polygons with right angles, but I'm just really struggling to see how this shape right here has a right angle. I don't know. Let's just go with it. Quadrilateral, no, not quadrilaterals. Polygons with right angles. And that would work for the shapes in the middle too, because the shapes in the middle are quadrilaterals and they do have some parallel sides, but then they also have right angles. And then the polygons that are just on the right-hand side have right angles. And I'm thinking that it's this corner right here that they're trying to say is a right angle. And I guess it is. I don't know. It's just kind of hard to see. And plus, it's very dark in my dining room. Should turn the light on, I guess. All right, so I think we kind of sorted out those polygons and came up with some labels. So moving on here, the on your own section. Let me zoom back out. So it starts to throw in a little bit of some review from some other chapters. So if you take a look at number 5, Ben and Marta are both reading the same book. Ben has read a third of the book. Marta has read a fourth of the book. And this is kind of setting us up for our next lesson as well. So you might be thinking, like, why are they talking about fractions when we're learning about shapes? But you'll kind of see that in the next lesson. But anyways, we're trying to figure out who read more, Ben or Marta. So I'm going to draw a rectangle. So when we think of books, I think of them being in the shape of a rectangle. And so there you go. Shapes are part of fractions. And then Ben read a third of the book. So that means I'm going to take his book and split it into thirds. Not very well. And just kind of scribble in here 1/3. And let's say the part that I'm scribbling in is what he read. And then Marta read 1/4 of her book. And so that means I need to split her book into 4 parts. Okay? And scribble in, trying to stay within the lines. Mrs. Glass would not be proud of my artistic skills. All right, so who read more? So when we think of these fractions, which fraction is greater? We have 1/3 being compared to 1/4. And if you remember anything about fractions, whenever the numerator is the same, we can compare the denominators. But we have to remember The bigger the denominator, the smaller the pieces, the smaller the size. So even though 4 is a bigger number, it actually means that her book was divided into 4 sections, so those sections are smaller. And so a third is going to be greater. So that means Ben read more of his book. Okay? Number 6, there are 42 students from 6 different classes in the school spelling bee. Each class has the same number of students. Use the bar model to find how many students are from each class. So this, boys and girls, is simply a division problem. We have a total of 42 students, and we are dividing them among the 6 different classes. And so there are 6 different parts of our bar model here. And we need to figure out what number would go in each section of the bar. So 42 divided by 6 equals 7. Because I know 3 7s equals 21, and if I double that, it equals 42. So this should be an equal sign. 42 divided by 6 equals 7. Okay? All right, for this next one, it is a Think Smarter problem. I am going to show the math on the spot video. As long as you follow along in the video, you don't need to write or draw anything additional because it wants us to create a Venn diagram to show one way that we can sort a rectangle, a square, a trapezoid, and a rhombus. So as long as you watch the video here, which you kind of have to because you're stuck with me, then you don't have to do anything for number 7. Okay, so let me get the video situated. My computer has been moving so slow lately. It is just working way too hard. So bear with me, please.
Remind me of a Venn diagram. Let's look at today's puzzle. It has to do with Venn diagrams. Draw and label a Venn diagram to show one way you can sort a parallelogram, a rectangle, a square, a trapezoid, and a rhombus. Let's look at our shapes. Here we have them so that you can see what they look like. Now, before we start organizing these in a Venn diagram, let's think about what characteristics they have. Well, they're all quadrilaterals. So, if we can place them into 2 different categories, we can form our
Hi there. You know what these remind me of? A Venn diagram. Let's look at today's puzzle. It has to do with Venn diagrams. Draw and label a Venn diagram to show one way you can sort a parallelogram, a rectangle, a square, a trapezoid, and a rhombus. Let's look at our shapes. Here we have them so that you can see what they look like. Now, before we start organizing these in a Venn diagram, let's think about what characteristics they have. Well, they're all quadrilaterals. So if we can place them into 2 different categories, then we can form our Venn diagram. Well, some quadrilaterals have a pair of parallel sides, and some quadrilaterals have 4 right angles. So we can form a Venn diagram with these two characteristics. So let's look at our figures one by one and see which ones belong where. Here we have the parallelogram. We'll look at these two sides. These are a pair of parallel sides, and so are these. So in fact, it has two. So it has at least one. Now, let's see if it has 4 right angles. Well, if we look at the angles, they're not right angles. So this one belongs here on this side. Next, we have the square. Here we have a pair of parallel sides. Here's another pair of parallel sides. Also, the square has 1, 2, 3, 4 right angles. So where do you think the square belongs? If you said where the Venn diagrams or the circles overlap, then you are correct. Right there. Next, we have the rectangle. Again, here we have a pair of parallel sides. Here we have another pair of parallel sides. Also, the rectangle has 1, 2, 3, 4 right angles. So again, where does the rectangle belong? Yes, right here in the overlap. Next, we have the trapezoid.
Right, so
and we have a pair of parallel sides right here.
Sides that they have, and
now, does the trapezoid have right angles?
The ones that had right angles.
No, so the trapezoid belongs here. Next, we have the rhombus. And the rhombus has a pair of parallel sides here and a pair of parallel sides here. What about the angles? Those are not right angles. So our rhombus also belongs here. And there you have it. We just classified our figures and used a Venn diagram to help us. Classifying shapes allows us to see the structure and beauty of objects all around us. Enjoy looking for shapes in your life, and I'll see you next time.
That 9 times 8 equals 72. So she has 72 squares. All right, and number 9, sketch where to place these shapes in the Venn diagram. So we need to draw in these two shapes. We have a triangle. So our categories are polygons with all sides of equal length and then quadrilaterals with right angles. Well, this first shape right here is definitely not a quadrilateral, so it would not go in the middle, but it does have all equal sides. So we would draw that triangle down there. Let me try that again. And then the second shape is a square. So, excuse me. So it has all equal sides, but then it also has right angles. So that shape we would put right in the middle. All right. Next page should take us to our practice and homework. And so we look at number 1. We have the Venn diagram here that Steve drew. It's already done for us, but it doesn't hurt to just look. We needed us to help sort the shapes as to what categories they belong to. So we have triangles, and then we have polygons with right angles. Well, A was simply a triangle. It doesn't have right angles. B is a triangle, but it does have a right angle, so Steve put that in the middle. E is a triangle, but it also has a right angle, so E is in the middle. And then C and D are not triangles, but they do have right angles, so they would go just in that category, polygons with right angles. All right, now we have Janice, and she drew the shapes below, and we need to put the shapes accordingly in their correct locations of the Venn diagram. So we have polygons with right angles, so those perfect corners, and then polygons with all sides equal. So I'm going to look first for the right angles. A has right angles, but does it have all equal sides? No, so it only goes in the first part of the Venn diagram. Let's go with B. B has right angles, but does it have all equal sides? No. So B only goes on this side of the Venn diagram. C. C has a right angle. Does it have all equal sides? No. So it goes just on the left side of the Venn diagram. And letter D is a square. Does it have right angles? Yes. Does it have all equal sides? Yes. So it actually goes in the middle, and nothing goes on the right side of the Venn diagram. Okay? We're going to skip over number 3 and go on to the back. What shape could go in the section where the two circles overlap? So looking at this Venn diagram, they want us to figure out what shape could go in the middle, which means it has to be a quadrilateral with 4 right angles, and it has to be a polygon with all sides equal. So can you think of a quadrilateral that has 4 right angles and all equal sides? I'm thinking of one. Not a very good drawing of one, okay? But we've got a square. Hopefully you guys get some humor out of my videos. Number 2, what quadrilateral could not go in the circle labeled polygons with all sides equal in length? Well, a rectangle couldn't because rectangles do not have all equal sides. Okay, so we could certainly put a rectangle there. Right? Number 3, how many angles are greater than a right angle in this triangle? Well, a triangle can only have one obtuse angle. Otherwise, you wouldn't be able to close it. So there is 1. How many sides of equal length does this triangle appear to have? To me, it looks to be 3 equal sides. And do you remember what we call a triangle with 3 equal sides? Equilateral. Okay, so it's an equilateral triangle. And number 5, Madison drew the shape. How many angles less than a right angle does it have? So how many acute angles does that shape have? And if you look carefully, it has 0 acute angles. They are actually all obtuse. And number 6, how many dots are in half of the group? So half means we want to take our total and split it into 2 equal groups. So I'm going to divide it straight down the middle here, and then we're going to look at 1 out of the 2 parts. And I see 9. Kind of looks like I made a 9 with the green pen. I didn't mean to do that. Okay, so 9 dots are in half of the group. All right, guys, thanks for hanging out with me yet again for another math video. I may post a review later this week. Next week, though, is the end of the chapter, so we'll certainly be doing some more review next week. Sadie's popping in real quick, just got her bath. Anything you want to say to our friends?
Bye, guys.
All right, she says bye, ta-ta for now, and we'll see you guys later.